Mmke is a multimodal knowledge extraction system from unstructured texts. It has multiple functions. First, please let me have a brief introduction of our system. Our system accepts unstructured text as input, from which it automatically extracts triplet knowledge. More importantly, we incorporate a number of user-friendly extraction functions, such as multi-format uploading, one-click extractions, knowledge editing, and graphical displays. Here are the operating details of our system. The first thing a user needs to do before using the system is to determine the relation set. In our system, you can select multiple values to deal with the overlapping problems. Here, repetition is not allowed in single value. Here, you can easily upload multiple files. After uploading, you can click the Start button to extract knowledge. We provide the system's example file in Word or Excel format. Under this page, users can click on the knowledge to see where the knowledge is in the original text. Our system provides a download function here. We display the knowledge based on NEO4J. Users have the flexibility to edit the extracted knowledge triplets themselves. We also provide a simple search function in this page.
Next, we briefly introduce the motivation and the framework of our Mmke system. Generally, most previous relation extraction models divide the extraction task into two steps. They first recognize all entities from the sentence, and then predict relationships between each entity pairs. Though effective, these methods still have three limitations. First, these methods only focus on objects whose types are entities. However, objects can be not only entities, but also diverse types, such as tasks, numbers, addresses, events, etc. Second, they assume an entity pair only corresponds to one relationship. In fact, the overlapping problem exists widely in sentences. For example, the entity pair overlap, the single entity overlap, and the normal one. Therefore, existing methods are unable to handle such the problems. Third, researchers paid more concerns on predefined relations recently. While in open domain corpus, there are lots of relations that are non-predefined. Thus, existing methods lack an effective solution to the non-predefined relationships. In this work, we tackle the three limitations by proposing the multimodal knowledge extraction system MMKE. This figure shows the framework of the MMKE system. For an input sentence, the system first transforms the sentence into a contextualized embedding, then obtains hidden features of the sentence through a feature fusion and enhancement layer. After that, it predicts the relational triplets based on 3 subtasks, including the subject extraction, relation prediction, and the object extraction. As shown in the right part, the system contains 2 models according to different extraction orders. They are the relation SO model and the subject RO model. Let's introduce the relation SO model first. The model uses the BERT for contextual representation and follows by a bio-LSTM layer for feature enhancement, and finally apply a CRF layer for sequence labeling. The input of the model is the concatenation of the sentence and the task-specific information. In subtask 1, it predicts candidate relations with the multi-label classification, which uses the hidden state of the CLS token as the input. In subtask 2, it extracts subjects through the sequence labeling method and using the relations predicted above as the task-specific input. Finally, in subtask 3, it conducts object extraction in the same sequence labeling way, and using the predicted relations and subjects as part of the input. Specifically, benefiting from such structure, the relation SO model can deal with problems of diverse objects, overlapping relations, and their non-predefined relations. Next, let's see the subject RO model. This model tackles the relation extraction task with a question answering framework, and it uses diverse templates to generate questions. As shown in the left figure, it first extracts subject entities based on a QA formation. For example, if we have a sentence, David Tennant was born in England, and we want to identify person names from the sentence. So we can ask questions like, which words are person entities, or which person are mentioned, or find person in the text. Based on the BERT QA structure, we can find the right answer from the sentence, like, we can find the person David Tennant. In the second subtask, it predicts relations for the subjects. Here, the relation prediction is also a multi-label classification task and uses the concatenation of subject and entity-label embedding as the input. The third subtask is the object extraction. Similar to the subject extraction step, it finds objects from the sentence by answering the relation questions. For example, if we already have the subject David Tennant and the relation born in, we can ask questions like, where was David Tennant born? Or find location that David Tennant born? Or what is David Tennant's birthplace? And by answering the questions, the object England can be found. It is worth noting that the subject RO model is useful to handle the problem of non-predefined relations. When a user needs to find non-predefined relations, following the framework design, we first find the subject through a lot of fuzzy questions, such as, what is the body of this article? Then, we use the default question templates to traverse the non-predefined relations and find the objects. For example, what is the relation of the subject? In addition, we can customize the questioning templates of the non-predefined relations to make them more consistent with natural language questioning. Benefiting from this strategy, we can make obvious improvements in extraction performance.